Hi, I'm Kaylee, and I'm going to be giving a bit of background on magnetism, just so our article titled Ancient Trees Show When the Earth's Magnetic Field Last Flipped Out will make a little bit more sense. Magnetism is everywhere. It's pretty much in everything that we use on a daily basis, even what you're using right now, like your computer or your phone. Magnets contain two poles in them, a north and a south pole. The force between the magnets change depending on what poles you try to bring together. Like poles will repel each other, while opposite poles will attract each other. But there are no magnetic monopoles in nature. This basically means that even if you have a magnet and you break it in half, it will still have a north and a south pole. It'll just be a smaller magnet. Magnetic fields are always closed loops. They will never be open. They move from the North Pole to the South Pole and then go back to the North Pole by going the opposite direction inside of the magnet. The Earth's magnetic field is similar to a bar magnet with closed loops and the direction it moves. But every 100,000 years or so, the poles flip and the magnetic field reverses direction, and scientists aren't really sure why it happens. The aurora borealis, also known as the northern lights, is a phenomenon created by the Earth's magnetic field and by the sun spewing out radiation. So basically what happens is the radiation hits the magnetic field and is either moved south or north, and the movement of the radiation is what creates the light. So this can either happen in the north or the south pole. I hope this helps in understanding a little bit better how magnets and magnetic fields work.
Hi, my name is Haaz, and I'm going to tell you about the article that we found in NPR. It's called Ancient Trees Show When the Earth's Magnetic Field Last Flipped Out. As we know, our planet is a giant magnet. It's core is solid iron and molten metal, basically. But 42,000 years ago, for some reason that scientists do not understand, the magnetic field became unstable and its north and south pole flipped. How do we know this? Because scientists found lava flows in France that contain bits of iron that are basically pointed in the wrong direction. So, scientists have decided to look at trees and study the subject. The giant kauri trees in New Zealand, when these trees die, they end up well preserved in bogs. So the researchers and their college look for a form of carbon created when cosmic rays hit the upper atmosphere. More of these rays come in when the magnetic field is weak, so levels of this carbon go up. The trees, with their calendar-like set of rings, took in this kind of carbon and laid it down as wood. That let the researchers see exactly when levels rose and peaked and when they fell again. By creating a precise timeline, the research team was able to compare the magnetic field's weakening to other interesting things going on, like Neanderthals disappearing, large mammals dying in Australia, and the high solar radiation made humans seek refuge in caves, among other things. Thank you for your attention.
Hi everyone, I'm Iris and I am presenting the conclusion of our group work for the project article, Ancient Trees Show When the Earth's Magnetic Field Last Flipped Out. As Kaylee explained, we are surrounded by magnetism everywhere, and the Earth itself is a giant magnet that has a north and a south pole. It is surrounded by magnetic fields that protect it from cosmic radiation. These fields extend from the Earth's magnetic poles and occasionally flip, like when it occurred 42,000 years ago. According to the article, scientists now have linked the flipping of the poles to key moments in prehistoric era, as Marihel stated in her presentation. Now, scientists have known about this phenomena by studying kauri trees, or more specifically, the tree's annual growth rings that have revealed higher levels of radiocarbon caused by the collapse of the Earth's magnetic fields when the poles reversed. We know that magnetism is a physical phenomenon that is produced by the motion of electric charges that results in forces that either attract or repel. How does the Earth have its poles reversed? How does the magnetic fields become unstable? This is something that it remains a mystery. Thank you for watching and hope you have enjoyed our presentation.